So welcome to this segment of my videos as I try to look at the science paper 2, 2022. So let's try to see if we can answer section B together. It says answer all questions in this section. Write your answers in the spaces provided. So this is chemistry provided in this section. So the B1 says give one reason why laboratory rules are very important. So rules are important. There are so many rules that you need to know. They're important, possibly I would have said because they help to prevent accidents. They help to prevent accidents and ensure, safety. Yeah, so they ensure safety. If you want, you can end there when working with chemicals. So they do help, to actually prevent accidents, and also they ensure safety, especially when you are actually working with chemicals. Not only chemicals, possibly you could have said, and equipments. So that's what they do. Then it says state one importance of chemistry in our everyday life. So there are so many importance of chemistry in our everyday life. For example, chemistry, helps in the production. You can simply say helps in the production of, food. We can talk about maybe clean water. We can talk about fuel. We can talk about plastics and medicine, including the clothing that we are able to wear. So it helps in the production of food, clean water, fuel, plastics, medicine, extraction of minerals, making of detergent pads, and so many other things that they have. So chemistry is very important because it actually helps us in our everyday life. So you need to know a lot of them when it comes to the importance of chemistry. Look at B. It says the following graphs show heating curves that were drawn after pure ice and candle wax were heated over time to their melting point. So remember, pure ice, there are no impurities, but when it comes to candle wax, contains impurities. And basically, when you talk about something that contains impurities, it is going to melt or boil over a range of temperatures. But anything that has got no impurities in it, it simply means that it is going to have a fixed melting point as well as boiling point. But our focus here is simply on the melting point, and that's what the question says. So they have given us the two graphs. It says identify the heating curve for the candle wax and give a reason for your answer. So the candle wax, I would have actually gone to curve X. Why? Because you can see that it is actually sloping. It doesn't have a flat plateau, a flat surface like this one has. So you can see here the melting point is actually constant, and that indicates that this one is ice, but this one is representing candle wax. So that's the curve for candle wax. Now the question is, what is the reason why I'm saying that this curve is representing candle wax? It's because we can say that it melts over a range of temperature. It melts over a range of temperatures, giving a sloping curve. The reason is because of impurities here. Due to impurities. So that's the reason why it does. So it melts over a range of temperature. That's the key. No wonder it is actually giving us a sloping curve, which is actually not flat as compared to this one that you are able to see there. Hopefully you are getting some points that will help you even as you revise. Look at 2, Roman 2. It says give one effect of impurities on the melting and boiling point of a substance. So in terms of the melting point, what do impurities do? So in terms, if at all there are impurities in a substance, then impurities, I can simply say impurities lower the melting point. So impurities lower the melting point, but when it comes to the boiling point, impurities raise the boiling point. So that's the effect of impurities that they have. So in terms of melting point, impurities will lower the melting point. In terms of boiling point, impurities actually raise the boiling point. So that's what you need to remember in our discussion there. Then B2 says study the following flowchart and answer the questions that follow. So let's look at the flowchart. There's liquid P plus liquid Q mixture, and that mixture is what they are calling as being mixture X. Then when they have this mixture, there's no distinct layer seen between P and Q. So mark that word, no distinct layer that you're able to see between P and Q. Then this a mixture is, they use technique T, separation technique T, to separate them. Now, one thing that you need to remember is that if you are able to see a layer between, if you are able to see a layer, you have got two layers that you have, then those substances are called as being immiscible. If at all they are liquids, then we call them as being immiscible liquids. But if you put them together and you are not able to see a layer, it is only one layer that you're able to see, then those are simply called as being miscible. Those are what we call as being miscible liquids. So because there's no distinct layer, it means that P and Q are able to mix homogeneously to form up a miscible liquid. Now notice what they say, what are the liquids P and Q in the mixture X code. So for miscible liquid, a very good example is water and what we call as being ethanol. This is a very good example. They are able to mix properly. So either P or Q could have either been water or that. So P and Q could actually have been, water, yeah, but or ethanol. But wait a minute, it says what are the liquids P and Q in mixture X code? So what do we call them in this case? So we call them as being miscible liquids. So that's the best word there, miscible liquid. What is the separation technique T? Remember, these have got different boiling points. For example, water is 100 degrees and ethanol boils at 78 degrees. So the separation techniques that uses the property of boiling point is called, the separation technique is simply called as being fractional. So we can call it as being fractional distillation. The criterion, so what's the property, the criterion? The two, liquids have different, they have got different boiling point. No wonder we're using this criterion or technique there. Then deduce the names of liquid P and Q. Like I said, it could have either been water and it could have been ethanol. It doesn't matter which one you labeled. I might have labeled this one as being ethanol and this one as water. As long as you have actually named them, then there's no problem with that. Let's go to B3. Remember, we are looking at the 2022 chemistry paper 2, science. That's what we are looking at there. That's the question I'm revising, section B. The following symbol shows a nuclide of element A. So this is a nuclide of element A. Distinguish between the number 16 and 32 shown in the nuclide for element A given. So remember, the number at the bottom there, 16, is representing what we call as being the proton, sometimes known as being the atomic number. Then the number on top, 32 there, is sometimes called the nucleon, sometimes we call it as being the mass number. Or as you you actually say the relative atomic mass, there's no problem. So distinguish between the number 16 and 32 shown. So 16, I can say represents, the proton number, which is just the number of protons in the nucleus, while 32 represents the nucleon number. So that's what I can say. So remember, proton number refers just to the number of protons in the nucleus, but nucleon number talks about the number of protons plus the number of neutrons in the nucleus of an atom. So that's what it talks about. Then B1, to which group of the periodic table does element A belong? So to which group? So you can write the electronic configuration. Since the proton number is 16, the electronic configuration in the first shell 2, 8, 6. To which group? It actually belongs to group 6. Why? Because if they tell you a reason, it has 6 electrons. So it has actually 6 electrons in the outermost shell, which we also call as being the valence shell. So there are 6 electrons. No wonder it is also found in group 6. So the number of electrons in the outermost shell will tell you the group number. But if you look at 1, 2, 3, the number of shells filled with electron will tell you the period of that particular element. So it says use the periodic table to identify element A. So if you go to the periodic table, you can easily identify element A. You just look at one with proton number 16. You can see proton number 16, it is actually sulfur. So sulfur is actually this element we are talking about. All right, then C2 says draw a dot and cross diagram to show the bonding formed in a compound between element A and hydrogen. So we can write the formula, element A and hydrogen, that's hydrogen and sulfur. Remember, anything, since sulfur is in group 6, it means it has a valence of 2, hydrogen has a valence of 1. So if you exchange, you are going to have hydrogen sulfide. So this is what we call as being hydrogen sulfide. So that's the compound that will be. So they want us to show using a dot and cross to show the bonding formed between these two compounds. So I can put up a key there. For example, I can put up a key and say, let the dot represent electrons of hydrogen and the cross represent electrons of sulfur. Remember, I'm just shortening that for electron. It's always good to put up a key because that's what you need, will help you to differentiate. So if you look at hydrogen, hydrogen has proton number 1, so the EC electronic configuration is just 1. So if you look at sulfur, sulfur requires how many electrons to become stable? It needs 2 electrons in the outermost shell to have 8. Therefore, the one that requires the most number of bonds, you need to put it right in the center. So I'm going to put up, I'm going to put sulfur right in the center. If I want, I could have written the inner shells. Sulfur is the X, so in the first one, I would have 2. Then I would have 8 in the second shell. 8, 2, 8. This is what I've written. Now remember, I said hydrogen will attach that side, another hydrogen will attach the other side. So the one that requires the most number of bonds is actually sulfur. So that's why we put it in the middle. Then these others are attached, especially when you're dealing with molecular or covalent bonding. So the hydrogen will put up, also the sulfur will put up. The hydrogen will put up, also the sulfur will put up. Now if you notice, out of the 6 in the outermost shell, sulfur has only shared 2, meaning 4 are remaining. So you put them there, they are actually unshared. So this is the bonding in what we call as being hydrogen sulfide, and that's what they wanted you to do there. Then it says compare the bonding in the compound formed in C1 with that of calcium oxide. So what the bonding? So I can simply say the compound in C1 above, contains, covalent bonding, while, calcium, oxide, contains, ionic or electrovariant bonding. Yeah, so remember, under ionic, this one involves actually the transfer of valence electrons between metals and non-metals, but when it comes to covalent, it actually involves the sharing, and that normally happens between non-metals. So that's what you need to remember. But this one happens between metals and non-metals, where metals will transfer their valence electrons to those. So watch out in my next video as we try to now, answer B3, B4, and some other questions there. Thank you so much for watching. If you love what we do, you can please subscribe.